Okay, 8.4, rotations. Again, if you're familiar with how to do coordinate points, then this should be fine. There's more complex ways to look at this, which we're not going to get into right now. I want you to understand that we're going to do everything based on counterclockwise rotation only. Everything's going to be 90 degrees, 180 degrees, or 270 degree rotation. If I ever tell you clockwise, or you ever see it on a test, nope. Just convert it into a counterclockwise rotation like we talked about yesterday. Okay, a rotation is a transformation in which a figure is turned about a fixed point, usually the origin. So a 90-degree counterclockwise rotation gets us to here, 180 degrees puts us to here, and 270 puts us to here. We'll only talk about that amount of angle measure, okay? We're not going to do 32 degrees or anything like that. So angle precision, rays draw from the center here to the same point over here, which should be the same distance and 90 degrees. So rotation is an isometry, a test hint. I'm going to ask you, a rotation is a reflection, transcription, isometry, dilation. It's not a dilation, it's not a reflection. I don't know what a transcription even is, so it's got to be an isometry. So graphing method on this one's tough. Not going to lie, you need to have a lot of different compasses and protractors, or a neighbor. You can use a neighbor's paper if it helps. Coordinate rules, most reliable, the one that you should use most definitely. Always use the coordinate rule. And then again, matrix multiplication, it can be hard. So not really worth the time or effort. So here's your rotation. All right, so AB becomes negative BA, AB becomes negative AB, AB becomes B negative A. Again, same process, we just plug in the rule. 90-degree rotation, AB becomes negative BA. Matrix form looks like this. You do have a matrix multiplication rule, but not worth it. All right, rotations are always counterclockwise. Don't forget, 180 degrees, AB becomes negative A, negative B. So if this is 2, 2, it becomes negative 2, negative 2. Easy enough. I like the matrix format because it helps for polygons. Again, we don't worry about the rotations. 270, AB becomes a B, negative A. So if this is a 2 on top and a 3 on bottom, then it becomes a negative 2 on bottom and a 3 on top. Again, we ignore matrix multiplication for now. A 360-degree rotation is kind of funny because it just gets it back on itself. So AB becomes AB. If you turn all the way around, you're still facing the same direction. Nothing's changed. All right, so rotation matrix. I show you what they are, but again, don't try and do the matrix multiplication. That's algebra 2 stuff. Okay, but here they are. If you want to try and use matrix multiplication, go for it. List the coordinates of vertices of the preimage. P, Q, R, S. Okay, so sorry, I went really fast on that. You plot your points, write down your equation, or your vertices with the coordinates here. Now, to get this to rotate, when you're given a certain number of degrees on the origin, okay? So if I tell you 90 degrees, you use the 90-degree rule. Top row becomes bottom row. Bottom row becomes changed sign on the top row. That's it. B becomes negative B on top. So 3, negative 3. 1, negative 1. Negative 2, change sign, positive 2. Okay, now if I tell you 180, I find the 180 rule. A becomes negative A. Doesn't change top or bottom, just change signs. B, change signs, there you go. So now, 270. Same concept. I have to plug in the rule. A becomes negative A. So I write it on bottom and I change the sign. B doesn't change signs, it just gets written on top. There it is. So it's just a matter of plugging in the rule that you're talking about for the specific amount of degrees you're talking about. So now, if you got into pairs with your partner, I want to show you that you can also physically rotate your paper the right amount of degrees. So the second person will just draw what they see on the rotated page. So here's 90, 180, turn it all the way around, and then 70, turn it all the way around a little more. So person 1 rotates their paper 90 degrees. Person 2 holds their paper like this. And if we look really close at these graphs, put them side by side, we just have to kind of ignore the fact that this is x and y. If I ignore that, then I can see that C is really just negative 1, 3. So on my partner's page, I go negative 1, 3, and there's my point. Here's B prime, and here's A prime. And so my person that I'm partnering with was able to draw it real fast just by looking at it. Now the coordinates for A prime, B prime, C prime are as follows. We could also do that, follow the coordinate change rule if you'd like to, but sometimes working with a friend works. So take some time, work with a friend. You're going to have a test question just like this, okay? Find the image matrix that represents the rotation of the polygon about the origin. Graph the polygon and its image. Notice, graph the polygon and its image. It really wants you to just graph the points. So first we graph negative 6, 0, negative 3, 3, and 3, 0. Connect the dots. All right. First step, graph the polygon. One problem, 1 point. Step 2, we have to convert it into the desired rotation. So I got to rotate it 90 degrees. I always use the coordinate rule. Personal preference, especially during tests. Okay, you get to choose your favorite method on the test. So I would use the coordinates, but I'll let you pick. So now, if I use the coordinate rule, I just simply say AB becomes negative B over A. So A gets written on bottom, B change signs and write it on top. There's my new coordinates. And my last point is for graphing the new image. So negative 6, 0, there you go. Negative 3, 0, 3. There's my points. Okay. Labeling them correctly. A prime, B prime, C prime, A, B, C. Label your points, everything. I will be very meticulous on this. That's your perfection. Okay, that's 3 points right there. Mess up on any one part of it, I'll just dock you 1 point, and we'll move on. Okay, essential question. How does rotation affect the area of an object? What about the side lengths? What about the coordinates of the vertices? Okay. Summarize what you learned today. Here's your calendar for next week. Retest on Monday, 8.5, 8.6, 8.7 activity, and then we're going to do test on chapter 8. All right, then. You can do the review worksheet problems 6 and 13, and that's it. I'm done.